Hello everyone. Hello everyone. Today we will be discussing Leetcode Weekly Contest 385. There were four problems in the contest and I was able to solve all four of them. Like the problems were count prefix and suffix pairs 1, find the length of longest common prefix, most frequent prime and count prefix and suffix pairs 2. Before I continue further, can anyone confirm if audio and everything is fine? Okay, thanks Akash. And I will get started with the first problem first. First problem says count prefix and suffix pairs 1. You are given zero index string array words. Let's define a boolean function is prefix and suffix that takes two string str1 and str2. Is prefix suffix str1 returns true if str1 is both the prefix and suffix of str2 and false otherwise. For example, is prefix suffix aba is true because like you can see aba is prefix and aba is also a suffix here. While but is prefix suffix abc is false because abc appears as prefix but it is not equal to suffix here. Return an integer denoting the number of index pairs I and j such that I is less than j and is prefix suffix words I and words j is true. The constraints of this problem were small, like the number of words were less than 50 and the word length was less than equal to 10. So like one way would be like we can try out all the pairs over here and for each pair we can check if getting prefix it's a prefix or suffix or not. And like a way to do it in Python would be like let's take for n into len words. For j like this should start from I plus 1 because we have been told that I is less than j. S1 is the word. Now like let m be the length of S1 and n be the length of S2. If m is greater than n, like the length of S1, then it can never be a prefix suffix. So we should continue here. Otherwise, if S1 equal to first m characters of S2 and S1 equal to last m characters of S2, then we should do increase our count by 1. This was essentially the solution for this problem. One second. Okay, S2. Wait 1 second. One second. Why am I getting like this should be the first time characters and this should be the last time characters, right? I is less than j, words is both prefix and suffix. One, two, three, sign PA. One second, like I'm trying to figure out like where did I went wrong over here, like why the first answer says only three. A, A, B, A, B, A, and like the three pairs are like only A matches over here, right? And A, B, A also gets a match. Okay, like the issue is I am replacing overloading M and N. Like variables are not scoped here. Essentially the first problem, and like there was a harder version of this problem where the constraints was slightly higher. We will see how to solve them. And like no, like I generally code easier problem in Python and harder problems in C++. And for the next problem I will mostly move to C++ because I use C++ in the contest. And regarding Java, like unfortunately I have never used Java, so like I don't really know how to code in that language. You are given two arrays with positive integers AR1 and ARR2. A prefix of positive integers is a string formed by one or more of its digits, starting from its leftmost digit. For example, 1, 2, 3 is prefix of 1, 2, 3, 4, 5, while 2, 3, 4 is not. A common prefix of two integers A and B is an integer C, says that C is prefix of both A and B. For example, 565, 5359 and 56554 has a common prefix 565. If you notice, 5655 is also a prefix of this, while 1, 2, 3 and 4, 3, 4, 4, 6 do not have a common prefix. You need to find the length of common prefix between all the pair of integers x and y such that x belongs to ARR1 and y belongs to ARR2, and return the length of common prefix among all the pairs. If no common prefix exists among them, return 0. Like let's look at some of the examples here. So like in the first example, array 1 is 1, 10 and 100, and array 2 is 1000. And if you notice, one second. Okay, looks fine. In the first array, array 1 is 1, 10 and 100, and array 2 is 1000. And if you notice correctly, like this is the only word we have for the array 1, and the all of the elements in array 2 is prefix of it. So the max here is 100 over here and 100 over here, so the answer should be 3 in this case, which is 3. The second example was array 1 equal to 1, 2 and 3, and array 2 was 4, 4 and 4. And if you notice, like there is no common prefix between all the elements. Like the only element in array 2 is 4 and none of the elements in array 1 starts with 0. So we should output 0 in this case. The way I approached this problem was like I wrote a common method which takes an array and returns all the prefixes of all the numbers. And like once we have this method, then we can call it twice to get all the prefixes of both the arrays, and we can put them in a set, and the next task would be to check like if both the sets have any common elements, and for all the common elements we should take the maximum length and return it over there. And the method to generate like all the prefixes would be, let's say we have We can, for C++, we use method to string, which if you pass on some method, it gives you a string s. And now you can iterate on the complete string, and you can maintain an empty strings to start with. Then t plus equal to x will give you all the strings. You put them in a set like this and keep doing. Like, the problem was more on an implementation side rather than like trying to figure out like what needs to be done. And the question is, why is this sufficient enough? So you may notice that the array size is up to 5 feet 10, and all the elements are between 1 to 8. So the like maximum length of any element is 9. So like for each element there can be at max 9 prefixes because the maximum length is 9, and because the maximum number of element is 5e4. So like maximum elements we will have in our set would be around 9 into 5e4, which would be around 45 into e5. Like, these are the maximum number of prefixes for a particular array. And now if you put them in set, then you can also check the other part. And like, this was essentially the idea I had. And I will mostly go and code it now. Like, beware of using set or dictionary in Python over here. Like, you can check out my recent video, like how to play cat and mouse game, where like I have mentioned like how you can hack set and dictionary solutions over here. So like, this was essentially my solution. Like, array p1 is the set of strings which gives me all the prefixes for given array, and array p2 is a set which gives me all the prefixes for the array 2. And now my answer is 0 right now, and I am iterating over all the elements. Like, while like I am using two pointers, one for the first array and second for the second pointer. And if I found like now these elements are also in the sorted order. If the two strings are equal, then I take max of current string length and increment both the pointers. If otherwise, I increment the pointer which is smaller over here. Like, I think a better way would be to just iterate on one of the sets and check if the second string exists. Like, the reason I did not try it was like the time complexity here would be like the length of this string and log an additional log factor for this count over here. So, and this may end up impacting like, already our solution is around 5v5, so like, and like we may have a log factor, and there may be a chance that it's a TLE. Like, let's see it. Okay, wait. Okay, we should also iterate on the second part as well. Okay, size of p, instead of size of p2, it should be the length of it. And the way to get all prefixes over here would be, like, we iterate on all the numbers of a. We convert it into a string using toString method in C++. Now we maintain an empty string. Like here, or we can also iterate on the length of the prefix and try to use s.str method, and then we can insert this string over here. So like, a method to get all the prefixes of given array of integers. And like, then once we have an integer, like, we iterate on one of the list of prefixes. We check if a prefix appears in the second string. If yes, take answer with the max, and we are good. So any questions on this one, like, before I move to the next problem? Like, the Contest I felt was more on an implementation side. Okay, what prefix is taken over here? Like we have to like what the problem really wants us to do is like we have two integers. A1 is some set of number. Let's say 1, 2, 1, 1, 2, 4, 2, 3, 1, 3, 4, 5, and A2 is set of second numbers. Then we look at all the pair of numbers over here and like look at like what would be the like we have to find one of the numbers which is prefix of both the numbers. For example, if we look at this number here, its prefix are 1, 12, and 121. These numbers prefix are 1, 12, and 124. These numbers prefix are 2, 2, 23, 23, and 231. These numbers prefix are 3, 334, and 345. Similarly, if we look at all the numbers here, like here the prefix is 4, 45, and 456. Here the prefixes are 1, 15, and 156. Here the prefixes are 2, 23, 234. Here the prefixes are 5, 52, and 521. Like prefix means like a string starting from the first index and which is also present in that string. Like for example, if a string has length 3, then there would be three prefixes. One which consists of only first character, second which will consist of first two characters, and third which will consist of first three characters, which would be the complete string. And now when you know all the prefixes over here, like you have to find like which number appears in both of these lists. Like for example, like 4 does not appear over here anywhere. 45 and 456 also does not appear. While 1 appears here as well multiple times. 15 does not appears in any of the array. 156 also does not appear anywhere. 2 appears here. Like it is 23. 23 also appears over here. 234 does not appears here. Then 5 does not appear. 52 does not appear. 521 does not appear. So now among all the numbers which are in both of this, like we have to find the one which has maximum length over here. So here the common numbers are 1, 2, and 23. And the maximum length over here would be of 23, which is 2. So the answer should be 2 in this case. Yeah, like can put it inside and find the common, that is one way, and which would be optimal over here. The other way can be like we iterate on all the possible pairs of the array and try to find the common prefix. In that case, the problem is it can get really like 5 into 10 to the power 4 square would be around 25 into 10 to the power 8. And then the length of max string can be 9 as well. So like that's essentially the solution. Like you can also use unordered map, anything works, like, but beware of the unordered map. It's possible to easily get hash collisions on unordered map. And you can check out my recent video like playing cat and mouse game featuring Leetcode contest to see like why unordered map can get hacked for TLE after the contest. So like this was essentially the solution, a method to get all the prefixes for all the numbers, put them in a set, and then iterate on all of them and find the larger one. Now I will move to the next problem. Find the length of common prefix. Like this is the problem which I already discussed. This one says most frequent prime. You are given m into n zero index 2D matrix mat. For every cell, you can create numbers in the following way. There could be at most 8 paths from the cell, namely east, south, southwest, west, northwest, north, and northeast. Select a path from them, appending digits in this part to the numbers being formed by traveling in this direction. Note that the numbers are generated at every step. For example, if digits along the path are 191, then there would be three numbers along the path 119 and 191. Return the most frequent prime greater than 10 out of all the numbers created by transversing matrix, or -1 if no such prime exists. If there are multiple primes with highest frequency, return the largest among them. So for example, if this is the matrix and if we start traversing from east on this direction, we will get two numbers, 1 and then 11. If we traverse southeast, then like one number we will get is 1 and the other number we will get is 19. And if we try to traverse south, then this would be our path 119, 191. And like also, like we can also choose one of the like select a path. So like the starting path is not necessary, this is the index. We can also start from this 9 and traverse out, so we will get 91, 9 and then 91. If we traverse in like this direction, then the numbers we will get is 9 and 91. So like there are two parts to this problem. One we can do is like we can like generate all the numbers by traversing all the like we can fix a starting index. We can fix starting position and direction. We can fix starting position and direction. And then we can traverse in all the direction to generate all the numbers over there. Like for example, if we fix like for example if we fix a number over here, and if this is our direction, then we would get three numbers along this path. So what we can do is we can fix a starting number, and once the direction has been fixed, we keep traversing over there until we move out of the grid. That's the case when that number is no longer like we cannot form any numbers. And we can create a frequency hash map, or like we can use a frequency map and to maintain frequency of each numbers. What we need is like yeah, for example, if someone asks like 119191, like we have to only traverse in only one of the direction over here. Like it's written like first we choose the direction and then select a path appending digits in this path on the numbers being formed by traversing in this direction. Like we cannot change a direction over here. Look, it is invalid to change direction during the move. Like this note was really important. Like it's not really obvious looking at the text here. Like we can, and like then we need some method to check very fast, like if a number is prime or not. Yeah, like if any direction is allowed, then you should use DFS and brute force all the ways. Then we have to also check if a number is prime or not. Very fast method. And once like we have computed all the numbers, we can iterate on this map. For each number, we can check if it's prime or not. If it's prime, then we can compare its frequency and like the comparison to find like the number we have. And like the numbers can be up to length 6. Like so if you try any direction, like then the maximum number you can get would be of 36 digit length, and it's TLE like. And because like we can traverse only in one of the directions, so like, and because and an m is less than equal to 6, Then the maximum number we can get will have length 6 only. So like if we know for each number from 1 to 1 is 6 whether it's prime or not, then our path would be easy. And like to pre-compute if a number is prime or not, we can use sieve algorithm. Like given like it for each number from 1 to n, it computes whether a particular number is prime or not in n log n. So I will put it in the chat like what the Sieve's algorithm is. The idea is like you do sieve only once. Like if you start doing sieve for every test case, then you are just one. Like you can probably define a DP method outside your algorithm. So the way I did it was like first a global map for computing sieves of all the numbers of length up to 6, where I am checking like if I already computed the numbers, then I should not recompute it. Otherwise, I mark the numbers as false, start from P up to max, and then P into P, like which are the primes, and mark them as false. Because I do not want any number less than 10 to, so I just went ahead and marked 2, 3, 5, and 7 as composite number as well. Like that's not really required. If we have already computed which numbers are prime, we should not call it. And like once we have known all the directions, now we can fix the direction of x and y as well. We also fix the direction. If both the numbers are 0, that's an invalid direction because now you would be stuck on the same place as well. Now we also brute force on all the starting indexes. Now we also maintain a current number. It starts with 0 and we keep appending the digits to it. As long as we are in within boundary, like at least we haven't moved out of the boundary. Like to append a new digit at the back, we multiply existing number by 10 and add a new number at the back of it. Like for example, like if we are traversing on a path which has digits 1, 2, 3, 6, 7, then the first number we will get is 1. The second number we want would be 12. Third number we want is 123. Fourth number we want is 123.6 and 123.6.7. And if you see like all the numbers essentially are multiply this number by 10 and add new digit to it. Multiply this number by 10 and add new digit to it. Multiply this number by 10 and add new digit to it. I am also maintaining a frequency map. and then take one step in your current direction. Like let's assume the answer is 0 and frequency 0, and now we iterate on all the numbers we have got. Frequency of x. If the current number is less than 10, continue. If current number is not prime, continue. If the current number's frequency is less than our answer frequency, continue. And because in C++ the numbers are in sorted order, we can directly say that the answer is current and answer frequency is current f. Or if we could have added a check if f equal to current frequency, take the max. For if you are using an ordered map, you might need it. This was essentially the solution for this problem. Any questions on this one before I move to the next problem and last problem for today? Like trial division might work because like if you look at the numbers, like they are not really much. So like different starting positions are 36 only, and among the starting 36 position you have 8 directions, and the length of any number is at max 6. Like this is the length of maximum numbers you can get in a test case. Like like this is essentially DFS only, where you are fixing a direction and moving in the direction. Like whether you want to create an explicit graph or an implicit graph, it's up to you. So like this was the idea. We'll move to last problem. It was an harder version of the original problems. Like some prerequisites will be expected. Like there were two solutions over here. The easier one was hashing, which I used in the contest. And the non-trivial one is to use try. So like you can read like how to implement try. Like I will share some resource on them as well. Mhm. Like try and like you will need prefix or that algorithm to find whether a particular string is a prefix or suffix or not. Like you can read about try here. Like I will share the same part. And like the way to do hashing was like what I essentially did was I iterated on increasing order of I. When I am iterating on like S1, S2, S3, S4, S6, S10, let's say these are the given strings. Like there would be many approaches. When I am on S10, what I did was I have added hashes of S1 to 9 in a map. Now try all the prefixes. If prefix is also a suffix, then like check the hash of count of hash of prefix which is present how many times to the answer, and at last do it for all the strings. And the way I did was I tried to use rolling hash. Also beware, if you are using rolling hash you should randomize your base, because in the last contest few people in top 25 got hacked for using a fixed base. And you can again check out my same video, like catching cat and mouse, playing cat and mouse game featuring Leetcode contest, like how you should avoid it. So like for rolling as I am like rolling has is something like you can find here. You can take it offline, like read like about hashing offline. The way to do it was I took two prime numbers as mod and a randomized two randomized bases between 24 and 25. I have a boolean variable answer and I am maintaining hash in a frequency map. Then first I am iterating on all the strings in increasing length. Like I am doing something over here, like where I am iterating on all the prefixes from 1 to n and all the suffixes as well. Pair of HSS1 and HSS2 is the hash for the prefix. Between like HSS1 is base 1 and mod 1, HSH2 is base 2 and mod 2. And SHS1 and SHS2 would be like the hash for the suffix of the length j plus 1 basically. And then like I check current pair. If the hash of prefix of like I'm iterating on the length of the prefix and suffix, like let's make it a bit better. Prefix has one, prefix has two, like it would be a relatively different for maintaining like because when you have suffix, like you should add number in the starting. Like here I am running on the prefix. When I am increasing length I am adding new number at the back, but when I want suffix has, like I have to add a new number in starting over here. Prefix has, If prefix and suffix has matches and this number is also in the hash of all the strings you are maintaining, you should add it to the count. And when you are done with this algorithm, like you will have two prefix hash and suffix hash, which you can call string hash. And you keep repeating over here. Like here, I am also computing the power of bases to help me out create suffix hashes faster. Like when you iterated on the complete string, prefix hash is essentially the hash of the complete string. Like I think KMP or Z algorithm, one of them can give you like all the length of prefixes which are also the suffix of the same string. And like once you know, like you can even iterate on them, but you will need a fast way to check like how many times a particular string appears in the given array. And like you definitely can't use frequency map with a string because that will blow up the time complexity. Like string comparisons can take up to the length of the string over there. So hashing works. Try also work. Like I checked few people did try. So like it would be a fun exercise to try it using try as well. And like I doubt it would be possible to just solve this problem by knowing KMP or Z algorithm. Only one of them. Like only these, because checking like how many times a particular string appears in a given set would definitely require some hashing or some try based algorithm. And like this was essentially my solutions for today's weekly contest. If there are any questions, I can take them up. Otherwise, I will call it a day today. Yes, like you can use like the Z algorithm and hash. Like, can you explain the approach again with the example how it works? Like one prerequisite for this solving this problem is like understand how a string hashing works. Like I can take like the example in the given set once, or like the examples are not really good. So let's take some. Give me two or three random strings. I can do a dry run on them. Like the way to build suffix hash would be like you could have also like reversed the string and then computed all the prefix hashes of the reverse and then reverse the array back. That would have gave you all the suffix arrays in a length. Like let's take three strings. Like let's take this length. So first I have a frequency map where I am maintaining the count of each string which is initially empty. And now I am iterating on A, B, C, B. Like let's call it B, A. Now I iterate on the length. I first check like the length one prefix and suffix, are they equal? The answer is yes. Then I check like how many times they appear in this frequency map, which is 0. So I add answer plus equal to 0. Then I increase the length by 1. I check if AB and BA, like is AB equal to BA? The answer is no. So I continue over here. Then I move to the length tree. I get the string ABC and CBA. Both of them are not equal, so I continue. Then I go for ABC B and like BCBA. Both of them are not equal, so I continue. Then I check like the final five length string ABCBA. Like this is prefix going from here, and like also the last five characters ABCBA. Both of them are equal. So I check in this array like how many times ABCBA appears. The answer is 0. So I add answer plus equal to 0. And like once I have complete processing of this string, I add like this string over here. Like let's take some more example over here. Like let's say take these four strings over here. Now I move to the next string, which is ABC. I first check like first one character and last character A and C. They are not equal, so I ignore them. Then I check the first two and last two characters, which is A, B, and B, C. They are not equal, I ignore them. Like the comparison is done via string hasing, so it allows big of one time complexity. Like I can implement a solution like without string hasing, which is essentially same as the first problem. Like the difference in the first and the last problem is it was expecting you to do some hash solution or something. And like then I check the first three characters and the last three characters. They would be ABC and ABC. They are definitely equal. So I count how many times ABC has in this map. The answer is 0. So I add 0 to the answer. Now once I have completed the processing of second string, I have maintained like the same array over here. And then I move to the next string. Third, this is A. The first character is A, last character is A. So I count how many times A appears in this array. That is 0 again. Then I look at the first two and the last two characters. They are not equal, so I ignore them. Then I look at the first three characters and the last three characters. They are equal. So I count how many times ABA appears in this map, which is 0. So I add 0 to the answer. After I have completed the processing the third string, I add ABA over here. And my fourth example is ABA, BA. I first check first and last character. They are equal. So I count how many times A appears here. 0. So I add 0 to the answer. Then the second, first two and the last two, AB and BA, they are not equal. I ignore them. The third, first three and last three is ABA, ABA. They are equal. So I count how many times ABA appears over here, which is 1. So I will add 1 to the answer. Then I check first four and the last four. They are ABA, AB and BA, BA. They are not equal, so I ignore them. Then I take first five and the last five characters, which is ABA, BA and ABA, BA. They are equal, so I count how many times ABA, BA appears in this string, which is again 0. So I add 0 to the answer. Like if you want to look at like a plain brute force solution for this problem, and like a brute force approach would be like this is the prefix suffix I have. Like this will definitely get TLE, but like this is the brute force algorithm for over here. It will get TLE because the time complexity is way too worse over here. MLE, TLE, everything happens. But if you try the same algorithm on the first problem, it gets an AC because the string length is way too small. So the way to do like the algorithm is same as the first problem, but now you need some advanced string related algorithms to do it faster. So like this was essentially the idea. Thanks everyone for joining today. And if there are no more questions, I will call it a day.